Welcome back for day 3 of topic 6A, climate. And so we've talked about types of climates, the influence water has on climates, the influence mountains can have on climates to some extent. And today we're going to continue on in that process. So, climate and moisture. So, temperature is only part of it when it comes to climate. You have to consider how much water is available. Now, it gets a little interesting here because how much water you get is only part of it. You'd think like, oh, I get lots of rain, so therefore I'm a wet climate, but not necessarily. If you get a lot of rain, but at the same time it's just really hot where you are, that same rain can evaporate away and leave the ground dry. So there's a balance between the moisture you get and the temperature you have, and they interact with each other. So the moisture level of a region's climate depends on the balance between your need for moisture, how much water do you actually need to sustain conditions, and supply. Now, the need is determined by the temperature. If you live in an area that's cold all the time or barely above freezing, you don't need much water. If you live in an area that's hot all the time, water evaporates very readily from that, then you're going to need a lot more water. So the need for moisture is determined solely, like underlined circle, exclamation point next to solely. The need is determined by the temperature. So the warmer it is on average, the more water you're going to need to cover your usage and what evaporates away. So moisture need varies with location because your latitude is going to affect your temperatures. Your elevation is going to affect your average temperatures. And we've talked about that. That was in the prior 2 days. And of course, your season determines it too. We live in that temperate type climate where it's really hot in the summertime, so we need lots of water. But this time of year in February and March, it's not terribly warm. So we don't need water, but if you look outside, there's a lot of water sitting out there in the form of snow that's going to melt here in the next few weeks. So we'll have a big supply of water even if we don't need it. So a region's moisture supply comes from precipitation. The water you get has to fall from the sky. So it's going to fall as rain or snow or some form of precipitation. If you have a humid climate, we mentioned this term yesterday or the day before. If you have a humid climate, a wet climate, that means your supply is greater than your need for moisture. You're getting more water than you necessarily need to keep the ground at its current state. An arid climate is going to have a big need for moisture, but not enough supply. So it ends up being dry. You need a lot, but you don't get it. It's dry. So the two terms that go along with this are pretty common terms in everyday life, surplus and deficit. If you have a surplus of something, it means you have more than enough. So when there is a surplus of water, that means your supply is greater than your need. You're getting more precipitation than you're losing to evaporation from the ground just due to the temperature. Or plants also pull water out of the ground. So transpiration, if you remember that term from living environment. So evaporation and transpiration are where the need's going to come from. If you have a deficit of water, a shortage of water, that means you need a certain amount, but your supply isn't that big. So you need more than you have. So surplus, you have more water than you need. Deficit, you have less water than you need. Now, we'll kind of be focused on us. So here in New York, where we have a mid-latitude and humid climate, so we have seasons and we have quite a bit of water around. Since moisture need depends on your temperature, and we definitely have seasons, there's going to be a variation in moisture conditions. So in the summertime, when the temperatures are higher, that means we have a high need for moisture because water is evaporating pretty quickly and plants are growing and they're pulling water out of the ground. And that often means that by the end of the summer, we have a deficit of water. You might live out in the country where you have a well, and some unfortunate people have the situation where their well goes dry in the summertime because the water in the ground gets used up. We don't have a big enough supply to keep it at the level it was at. So, if you have to mow the lawn, think of when you mow. In May, you probably start mowing. In June, you mow a lot. May and June, you just can't keep the grass down, it's growing so fast. Early July, maybe even. But by the time we're heading back to school or sports practices start in the fall, that grass is pretty brown. And as a result, you don't have to mow very often at all. Some years the grass completely stops growing because it's so dry. So our need for moisture is great in the summertime. It might be greater than what we have. Now, for the whole year, though, if you add it all up, how much we need to how much we get, we have more than enough. But we just have a shortage in those summer months where it's pretty warm. In the wintertime, in the fall, in the spring, honestly, in all of those, uh, our temperatures are lower. Our water supply is still pretty good. And so we have a low need, but we have more than adequate supply. So we have a surplus of water most of the year. Now, our biggest surplus is going to come at the time of the spring thaw, which is coming here in the next few weeks. Because all winter long, or a good chunk of the winter, we've been building up snow and ice on the ground and in the ground, and it hasn't been used at all. So we have lots and lots of extra laying around. Plus, in the spring, we start to get rain, and usually it's some of our rainier months, a few inches of rain per month easily. So you're going to melt all the snow and ice. You're going to add the normal amount of rain on top of that. And it's still pretty cool in the spring, so you don't need all of it. So we have a huge surplus then. As a result, that's when rivers run the highest. That's when basements flood the most. That's when there's tons of puddles in your yard, the whole shooting match. That's when we have the biggest surplus. All right, so next sort of localized condition here. If you live along a coast, now here in our district, we do have people who live on Pillar Point, right near the lake, so that's good enough to be a coast. And if you go to the beach or you hang out next to the water for any amount of time, one thing you'll notice is that it's windy, like almost all the time it's windy. And that has to do with the fact that we've already mentioned that the temperature of the land and the water tends to be different. They heat up at different rates. So along an ocean coast or along a lake shore, during the daytime when the sun's up, the land is going to heat up faster than the water. And when it does so, warm air likes to rise, cold air likes to sink. That's still the same that applied back when we were talking about weather a topic ago. So during the day, warm air is rising rapidly over the land, and air over the water is cooler, so it's probably going to be sinking there. So that creates a pressure difference. You have low pressure over the land where the air is rising and less dense and warmer. You have higher pressure over the water where it's sinking down. And so you end up with an onshore breeze during the day, typically. So it sets up like this. So warm air rises off the land and cooler air sinks over the water. So you have high pressure over the water, low pressure over the land. Winds always blow from high to low. So the winds are going to blow in your face if you're at the beach during a nice warm day. Pretty much guaranteed. It's an onshore breeze. At night, things change. If you've ever gone swimming at night, the water feels so much warmer. It's like, whoa, what happened? Well, it's not that the water's warmer than it was during the day. It's just that the land and the air around the land got cold faster, so you're used to that. So the water feels warmer. It's kind of an illusion there. So at night, the air over the land cools off faster. The land cools off faster, so the air sinks there. Over the water, it's warmer now, so the air rises there. So the situation flip-flops. Now we have low pressure over the water, high pressure over the land, and at night the wind will switch and blow outwards. So we have an offshore breeze typically in the evenings in this situation. If you hang out at the water like you're camping at Wescott's or something, if you hang out at the water for several days in a row, you'll notice this pattern. During the morning, there'll be a time when it gets pretty calm, when the temperature of the land and the water are about the same. Then during most of the day, it's going to be an in-your-face breeze off the water. Then in the evening, everything settles down again because the land and the water get to a balance point where they're about the same. And then the wind will pick up again more gently, usually at night, and it'll go out. It's just a normal pattern you get if you're by the water. Doesn't matter if it's the lakeshore for us or an ocean shoreline, you're going to have the same situation occurring. That's one of the reasons they want to build windmills near water or in just offshore, because there's a pretty steady supply of wind. So these diagrams, they look the same. That can tend to trick people. So you really have to pay attention to this. I want to kind of stress this. You're going to have a worksheet where you have to answer these questions. So onshore breeze during the day, that one, warmer over land, colder over water, you get this convection cell forming. And in the evening, the opposite. So it sinks over the land, it rises over the water to get your offshore convection cell. So that's one type of horizontal air movement in that case. Now there's also vertical air movements, air rising, air sinking. We talked about that along fronts. That's a thing. So rising air masses found at fronts, we've discussed those, warm fronts, cold fronts, and so on. But it also happens along mountains. Mountains are a physical barrier that can't be moved by the wind, so the air has to go up and over it. They also happen at these places called convergence zones, which we'll get to and haven't talked about yet. So as air goes up, as air rises, there's less pressure on it because there's less air between it and space. And when it rises, and because there's less pressure on it, that allows the air to expand. Now, expanding air takes the same amount of energy it had, and now it's spread out over a bigger area, so it has a cooling effect. So air expands because there's less pressure on it. That has a cooling effect, and you're not adding energy to it to move these molecules apart, so that's why it cools off. It's called adiabatic cooling. Now, when you come down the other side of the mountain, the air gets compressed again because now there's more air between it and space. You take the air, you smush it back together, and there's less water in it. We've talked about the windward and leeward side of the mountains yesterday. So that causes it to warm up. So you actually end up with air that's warmer on the leeward side just because it went up and over the mountain range. That's one of the reasons it's drier on the leeward side. So rising and sinking air changes temperature without adding or taking away energy just because of the pressure changes. All right, so that's enough for today. You'll have a worksheet to do, and have a nice day.